Started. Welcome everyone to Builders Declare Australia's 26th webinar. It's Clinka, Sustainable Materials for Smart Buildings. My name is Hamish White and I'm one of the founding members of Builders Declare, soon to be Builders, Sustainable Builders Alliance. And I'm the Director of Sanctum Homes and I'll be your host for this evening. In the spirit of reconciliation, we'd like to acknowledge the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respects to elders past, present and emerging and extend our respect to all Aboriginal and Torres Strait Islander peoples today. Today, we are joined by Ryan Strating. Ryan has worked in the building industry for over 25 years as both an architect, builder and developer. An early passion for environmental design was fostered by mentors David Oppenheim at Deakin University in Geelong in the 1990s and Andreas Sederof at Sunpower Design in Melbourne in the early 2000s and led to the formation of Core Collective Architects with Dr Ceridwen Owen in 2003. Sorry, Ryan, if I completely butchered that pronunciation up.
I'll sort it out.
And he is also the director of Clinka Building Materials, a company that supplies robust materials and thermal detailing solutions for high-performance buildings. And that was formed in 2009, based in Gippsland. His technical approach to practice, consulting and material detailing are informed by the many years of first-hand experience in on-site delivery of unique creative construction projects, some of which have won state and national awards. For tonight's presentation, he will be presenting information about Clinka products using case studies to show how these materials can be used to simplify and enhance the thermal performance and performance and health of building occupants and the environment through robust detailing and ease of recyclability, both contributing to excellent LCA outcomes. As previously mentioned, Ryan is also the principal at architectural practice Core Collective, based in Tasmania. Is that in Hobart, Ryan?
Hobart, yeah.
Yep. Ryan has a record of successfully completed projects in the role of team leader and site contract architect. Ryan leverages his strong architectural design skills with a background in the broader construction industry. His collaborative... Sorry, you just have to excuse me because I just thought my other son was about to walk in the door. So this is the joys of working at home. I've got one son on the trampoline outside and the other one about to come through the door. Sorry about that. His collaborative approach and willingness to foster early stage engagement with contractors creates richer projects that are also risk sensitive. This has resulted in several state and national industry awards for projects of various scales and in diverse sectors. Ryan's knowledge and commitment to a sustainable built environment has informed his consulting role with other architectural practices and local government organisations through creation of material databases and thermal performance analysis, optimisation with a particular focus on integration with design team briefing to ensure practical, elegant and robust designs. Sorry about the interruption to the intro there, Ryan.
That's right.
Today's webinar is brought to you by one of our platinum founding sponsors, Wholesome. You may remember a previous webinar we did with Wholesome where we learned all about their low carbon concrete EcoPact. EcoPact is a low carbon concrete product range that can reduce the embodied carbon of buildings by up to 70% without offsets. EcoPact has a wide range of mixes available for different strengths and applications. And EcoPact is just placed and finished like conventional concrete. We've used this product a number of times on our projects, even on burnished slabs, and it finishes beautifully. For more information on Wholesome's EcoPact concrete range, visit www.wholesome.com.au. You can check out the Builders Declare webinar 14 on our YouTube channel. You can also check out Amelia Lee's Undercover Architect podcast, episode 280 and 281, where they've actually got one of the guys, one of their technical advisors from Wholesome on that webinar. On that podcast. Okay, let's kick off today's event. The information you're about to receive is based on the experiences of the presenters and may not relate to your situation. If you would like more specific advice, please get in touch with us via email. Today's webinar or presentation will be around 30 to 35 minutes, and it's going to give us heaps of time at the end where you can ask a whole bunch of questions. If you've got any questions throughout the presentation, please pop them in the chat below. I might jump in periodically and ask Ryan, or I might leave them all to the end and we'll start a discussion then. All right, Ryan, I'm going to throw it over to you now because my kids out the window are making a hell of a racket.
Turn the mute on.
I'm going to put it on now. Thank you.
Thanks, Hamish, and thanks to the Builders Declare team for inviting me to come along and present some of this work that we've been doing over the last few years with thermal design detailing for buildings. As Hamish said, my name's Ryan Strating and I'm the Director of Core Collective Architects and also the Director of Clinka, which is a company that provides materials and technical advice for thermal detailing. Tonight I'll be showing some examples of insulated slab construction with clinker, expanded clay aggregates and lightweight masonry. Our team at Core Collective Architects has been designing and building energy efficient buildings for over 20 years. As Hamish said, Core Collective is an architecture practice that was formed in 2002 by myself and Ceridwen Owen. We met at Sunpower Design in the early 2000s, as Hamish said, where we worked with Andreas and Dr Ceridwen on some of the highest performing passive solar buildings in Victoria at the time, which was a real pleasure and an insight. We were building some light and tight dwellings, and we're also building high thermal mass buildings. And at the time, under slab and slab insulation was relatively new and uncommon, and we were experimenting with different methodologies to avoid cold spots and provide slab insulation. Often the solution was polystyrene, which doesn't perform very well over time with moisture, and we evolved to using XPS, PUR, PIR in some applications, and aerogels even in some for thin spaces. But luckily, in about 2009, I met Paul Pellegrino, who was a Norwegian man living in Australia, and he was importing expanded clay products for his own use and looking to expand distribution. These products have been used for these types of applications for over 50 years in Scandinavia, so well-established materials. And Paul invited me to help him develop the products in Australia. And we formed a company with two other partners and set about naturalising these Scandinavian expanded clay aggregate products to the Australian construction industry and regulatory environment. We spent the intervening years testing various products in different applications. Not all of the methodologies used in Scandinavia are suitable here, and the climate's somewhat different, soil type's different. I'm going to show some case studies tonight that show a few different options for how clinker masonry and clinker aggregates can be used to insulate buildings to achieve a highly robust and durable building envelope. This is a few particles of clinker aggregates. So clinker products are all based on a standard unit, which is expanded clay aggregate balls. This product is made with a particular type of clay that's popped using an industrial process where clay particles are broken down into small pieces and they're put through a rotary kiln where they pop to multiple times their original size. It's sort of somewhat like popcorn, but the resultant particles have an internal pore volume and a very hard external ceramic shell. So the particles vary in size from very small, like dust, up to about 20 millimeters in diameter, and they're graded into various size ranges for different uses. The bulk material in size range 10 to 20 millimeters has a density of approximately 230 kilos per cubic meter. And so it's quite light, but also very strong, up to about 700 kPa in underslab applications, and it can have even higher crushing resistance for smaller particle sizes, such as the 4 to 10 mil range. Clinker aggregates have multiple uses in bulk form. It can be used as underslab insulation, the product on the right of the screen, and also for retaining wall backfill in a way that reduces potential loads on the retaining wall and remains stable and free draining for moisture control, and also used for civil applications like bridge abutments and stabilising swampy sites. 4 to 10 millimetre clinker aggregates are used to make lightweight concrete masonry elements that you can see here called clinker block, particularly for perimeter insulating formwork in slabs, permanent formwork for slabs, for substituting footings, and for external and internal wall construction. These clinker blocks are not only light, but they're load-bearing and very durable. For instance, a 150 clinker block wall that's rendered on both sides has a 4-hour fire rating, which as far as we know is the only masonry element in Australia that can do that in a single skin format. Clinker aggregates are also used to make lightweight concrete elements from lightweight no fines mixers, and smaller particle sizes can be used to make various lightweight concrete elements such as precast floor panels that you can see here going into a job in Inverloch in Victoria, and internal wall or intertenancy dividing panels. The crushed aggregates are used for green roof growing media, where it's blended with sand and a small amount of organics to make the highest performing and lightest weight green roof growing media available in Australia. And at least 2 of the case studies that I'll be showing you have an example of that. The use of clinker in building projects has a number of benefits: building performance, the health of occupants and the environment, and ease of construction. For instance, clinker aggregates and masonry are very robust. They won't burn and don't transmit fire heat loads very easily. The aggregates are chemically stable and natural, just simply made from heat and clay. And clinker fill is an effective anti-capillary barrier under slabs. When it's used more than 150 millimetres thick, it acts as a anti-capillary layer due to the high external pore volume in the product. Clinker block walls maintain a healthy indoor air climate for buildings, and they can contribute to mitigating condensation due to the breathability of the clinker lightweight concrete composition. Clinker products are easy to handle due to their light weight, but still exceptionally strong. They allow for simple, robust detailing and improvement on standard industry construction techniques as a step change, rather than radical revolution of construction methods. Installation of clinker aggregate into complex void shapes is also quite easy, as the aggregate can conform to the surrounding surfaces. So this is the first case study of a few that I'll be showing. It's an educational building for the Tasmanian State Government. It's the Mount Nelson Sustainability Learning Centre, and it was designed by Morrison and Breitenbach Architects and completed in 2011. Clinker provided the footing design detailing in collaboration with Richard Lawrence at Gandy and Roberts, structural engineers in Hobart. It's a unique building because it uses an insulated clinker footing block and underslab insulation to support a flagstone floor. There's no concrete slab as such. You can see in the diagram here, it just has a thin hydronic screed on top of compacted crushed rock that supports the stone pavers. And interestingly, the significant reduction in concrete by adopting these methods in the footings and the slab resulted in a building that far exceeded world's best practice sustainability principles and life cycle assessment, which was modelled by post-occupancy by ETOOL. And the building above floor level, which is quite interesting, the frame of the building was used from a demolished, repurposed from a demolished warehouse. for the primary structure, which further reduced the embodied carbon. The Sustainability Learning Centre is used as an education facility, and it's also the base for Greening Australia in Tasmania. And even though it's now 12 years old, it's still considered a benchmark for sustainable education buildings in Australia. This is a residential case study built in 2014, the Woodbridge Low Energy House. We built it as an example of high performance, high quality and robust small home for the Tasmanian climate. It uses clinker footing blocks in place of traditional concrete strip footings. They sit on a grid of board piers and filled with clinker aggregates to insulate the underslab. It has triple glazed windows. It was rated at about 10 stars, window U value around 0.8, 0.9, and it has clinker masonry for the external walls. Next case study is the Cascade House, which is my own family home. And it uses, we pulled out all the stops and used nearly all the clinker products that we had available to us. It's a relatively small 3-bedroom, 4-person family home. And it uses, like I said, a number of clinker products to achieve highly insulated building perimeter. The building is built on a north-facing slope and it's partially buried in the ground. So the ground floor is partially backfilled. The slab is upgraded to here to act as the retaining wall restraint, or the footing for the retaining wall, which avoids burying the footings in the ground that would create a dam for subsurface water. This means that the ground floor external walls and the slab are decoupled from the influence of ground temperatures, but also allow for water to move along underneath if necessary under the building, which reduces the load on the retaining walls. If the egg pipes are at capacity, it is in the water table. The ground floor retaining walls are a mix of concrete blocks and core-filled double clinker blocks, and are backfilled externally with clinker aggregates to provide external insulation to the buried walls. The internal walls are rendered and highly breathable clinker block, meaning that internal condensation and moisture control is partially provided by the breathability of these walls. The upper floor is a suspended slab, and the external walls are clinker iso blocks. On the roof, we have a warm roof framed with LVLs under a trafficable membrane, and a green roof that uses clinker aggregates for drainage and for the growing media. The plants are doing really well, and it's a very light green roof growing media, so fully saturated, it's less than 200 kilograms per square metre. So the LVL structure didn't need to be significantly upgraded to allow for that green roof. This is an image of the Cascade House under construction, so it gives you a bit of an idea of what the setup is like around the perimeter, using insulating lightweight masonry to both support the slab and provide permanent insulating formwork. This is the starting point for the retaining wall, and you see the clinker backfilled inside before the slab was set up. This is quite a different case study. This was a retrofit of an old barn in a heritage property in the Central Highlands of Tasmania. We were retrofitting. It's a heritage listed property, and we were upgrading the stables to be used as accommodation. So we needed to improve the performance of how it handled moisture. This is the original flagstone floors you can see before we did the renovation. They weren't appropriate for use, but for heritage reasons, we wanted to maintain them in place. The northern wall sandstone, which is partially buried. And so you can see here the cross section of this bottom corner. And this was the floor upgraded. This is the ground line. So an air drain was installed on the outside to promote subsurface ventilation and drainage of that existing stone wall, which obviously wasn't built to a waterproof standard by modern standards. And we put in a supplementary ag drain. And then internally inside the building, we used clinker fill, which provides insulation, of course, from the ground. It protects the original flagstones. And it has the benefit in this sort of application of providing an anti-capillary layer. So any moisture that does happen to get through the air drain and the stone wall and can't wick up through that layer and into the underside of the stone floor. The result was a warm and dry space. You can see the breathable strip drain that we have along the outside edge of the inside walls. We have done a number of other heritage projects with similar infill flagstone floors, and if any of the attendees want some information about that, just contact me direct. I can send you some standard detailing. Another new house project. This was the Sunnybanks house. It's an interesting case study because it deals with highly reactive clay sites, which make the detailing a bit more difficult for best thermal performance, because we need to think about minimising the action of differential movement between the foundation and the structure. It was built in 2016. It's around about a 9-star house, very low heating requirements. It's highly insulated slab walls and partial green roof. You can see here with clinker aggregates and triple glazing on most of the windows. You can see here the base setup where the clinker was laid in bags, which we sometimes do. It's not delivered in bulk. And the perimeter standard masonry. The engineer decided that we needed to connect the slab to the concrete footings due to that potential soil movement. It's not ideal, but because of the distance between the floor and the slab, and also, the footing and the slab, and also the insulation of the clinker fill here on one side and the clinker blocks on the other, the path of travel for that heat is quite long. So it's actually still quite high performing. Because some of the case studies that I've shown are on relatively stable sites like Class A and S sites, and also relatively minor like Class M sites, the detailing is relatively simple and easy. However, we know that the large majority of sites in residential construction are reactive clay sites, and they present a bigger challenge to slab detailing, as I mentioned, because of the highly reactive soils mean the structural design needs to provide support and restraint between the slabs and the footings, and that can be a path of travel or a cold spot. So typically the restraint is provided by connecting the slab to the footings in the ground, and we're currently working on this detailing option and variations thereof, where we are using established technology of screw piles integrated with the insulation and support around the perimeter of clinker block here and clinker fill under slab, and the restraints provided by these screw piles. It provides a very simple slab design, minimises the total volume of concrete, and it's quite easy to insulate under a flat plate, suspended slab on fill design. Again, if anyone's interested in this type of construction, maybe they've done it already, it'd be great to hear from you. If you haven't and you're interested in it, get in touch and we can prepare detailing that is applicable to your site conditions. While developing and testing these various options for clinker, masonry and aggregate, we found that the installation is very simple, and it's often carried out by owner builders. It's that simple, and they need very little instruction, or if tradespeople haven't worked with clinker products, it's pretty easy to get your head around it and be underway quite quickly in underslab situations where reinforcing is penetrating from the in-ground footing system or board piers. It's very easy to install because it self-conforms around the variable shapes, and it can be installed on rough surfaces quite easily. And it's self-compacting up to about 150 mil thick. I seem to have zoomed through the presentation pretty quick and got through the case studies, I wanted to make sure there was plenty of time for questions, and we can flick back and talk about any particular projects if any of the attendees have got questions. I know, Hamish, you may have picked up on some queries in relation to your own projects.
And I'm sure we can just start a discussion on as well, because I know that we're actually looking at using Clinka on one of our projects at the moment, as you and I have been discussing outside of this webinar. There is a question here: is it available in Perth? How do we get the product? How do we, if we want to get the product onto site, what's the process of getting it?
We currently import the products from Scandinavia and we deliver direct. So we sell wholesale. There's minimum orders because we can't just sell a pallet here and there. But if buyers want to get in touch with me direct, I can quote on site delivery. So we'll drop it off on site or to your depot. Having said that, we are working on local production. It's still a few years away, but we are waiting for some maturity in the kiln technology so we can use fully renewable green hydrogen fuels. And at that stage, then there'll be distribution in each capital city. But at the moment, it's direct wholesale through Clinka.
All right. So this is actually a question from me, if I may ask it. Do the Clinka blocks have an R value? And I guess I'm thinking in my application, and I know a lot of the builders here, they're particularly in our climate in Victoria. We need to insulate our slab edge. Do the Clinka blocks have an R value that we can then plug into the PHPP for our passive house projects, or even run it through NatHers?
Yeah, well, there's a technical design manual that's available for download on the Clinka website that has a list of the R values for all of the different products. Obviously, the thicker the block, the more it can insulate. They are significantly better performing than standard masonry. Standard masonry is very dense, so it doesn't provide good insulation. The Clinka blocks that you can see, like here's one, for instance, you can see the aggregates. So each particle or each Clinka aggregate has trapped internal air, which provides insulation. But the blocks also have, there's somewhat of like a no-fines mix. So there's external pore volume in the block as well. So there's R values and they get thicker as you go up. We do have a foam, what we call an ISO block, which is a 250 thick block that we use for single skin construction, rendered inside and out. I think this image here is that product. And that provides an R value of about 3.5.
Okay. Because that was going to be another question I was going to ask you. If we are continuing those Clinka blocks up as an external wall, if we're getting an R3.5, that's great. We also get the value of it being a big thermal mass as well. So you kind of get both ticks, high thermal mass and good R value. I know you touched on it quickly in one of your slides, and again, probably a selfish question from my side, but I'm sure other people in the presentation are going to want to know about it. You talk about using the Clinka blocks and Clinka fill on stable sites. So I know some of the ones you talked about are Class A and Class S. Can we talk a little bit more about using Clinka blocks and the Clinka fill on unstable sites, so Class M and above?
Yeah.
I know there was a slide here before, because if we can use this product where we're removing a hell of a lot of concrete out of the project. And I know, ironically, this is brought to you by Wholesome, and they do a beautiful EcoPack concrete. Removing the concrete out of it is still going to make it a more sustainable home.
Yeah, I think you use concrete where it really needs to be used and not where you don't have to. And this is the benefit of just thinking clearly about what the options are and working with a good engineer to find the best solution. We've done some volume calculations on projects where we looked at doing a 150 thick suspended slab on fill, like this one, We still use perimeter footings around the edge to provide support for the clinker blocks, and that is sized to suit the reactivity of the site or the span distance between these board piers or screw piles, whichever method you go for. But minimising the internal beams is really handy because it's so much easier to insulate the underside of a flat slab. And even by making that slab 150 mil thick to get your 2 layers of Rio, by the time you take out the beams, and to be frank, take away the risk of having too many exposed footings on a site, I think you could probably speak about the pain of what can happen when it pours with rain and you've got exposed footings everywhere. It's pretty hard to avoid them completely, but if you can not have holes in the ground that can collapse, and the risk of cost and time or under ordering on concrete or whatever there might be, just by creating a very simple solution. So we tend to like to try to make things that are pretty straightforward to build, and they make sense from a risk perspective and a performance perspective. And I think any of these systems can be augmented to suit any soil type. It's just that it's much simpler and easier to do on the less reactive sites. We've built sites on sand where we didn't have any footings at all. We're just laying masonry straight into the sand.
All I'm hearing is getting that team together early on in the piece so you can really nut out those details and work through all the options. Karen has asked what the bags are made out of that contain the clinkers, because I know we talked about it being a loose product, but I know when I was originally looking at clinker a number of years ago, I think when we talked, it was coming in bags. Just what are those bags made of, and does that affect the performance of it compared to just having it in a loose fill?
It's a good question. We don't typically, though some of those photographs you saw from older projects, we don't typically deliver the material in bags anymore, although it is a recyclable plastic if you choose to, empty the bag in there and then, you want to recycle the plastic bag. But it's delivered most commonly in 2.5 cubic metre bulk bags, which are plastic, and presumably recycled, but I could get back to Karen on that one. I mean, ideally the product is delivered in bulk, but sadly that needs to be very large quantities, multiple deliveries of very large quantities to make it worthwhile delivering in bulk, as in like you would with gravel, off the back of a truck. And hopefully stage 2, when we're manufacturing locally in the near future, that's what we can do. Side tippers with no packaging at all.
I can imagine the day that comes, we're just reversing a truck up to the slab edge and just or the footing edge and just dumping it in and then just raking it out and job done. I know how long we spend in detailing our XPS on our sub slabs.
Well, a vac truck also, Hamish, works really well. You can just pump it through a big, 3-4 inch pipe and just deliver it that way, even up to high level deliveries or onto rooftops. That's how we do it with green roof growing media.
So there's of course going to be questions about lead times, minimum orders, and costs. So let's dive straight into them. So Elizabeth asks, what kind of money are we talking about in comparison to, for example, XPS in other subslab insulation?
Well, the price, I can talk about the price of the clinker products. People can do their own comparisons with their suppliers for XPS. To get equivalent R value for 50 mil or say 60 millimeters of XPS, you're looking at about 150 millimeters of clinker fill. So it's around about, depending on where you are, somewhere between around about $80 a square metre for clinker. And keeping in mind that, it's relatively easy to install. So, to take into account your labour component, I mean, XPS is not difficult to install. Each have their merits. I mean, we use XPS on some projects where thickness is an issue. You don't want to use 150 millimeters thickness, or you don't have it, or it might be a rooftop with a parapet and you need to get everything in 50 or 100 millimeters. So we sometimes use XPS where it's appropriate, but our preference is where possible to use natural products. It's easy to install, especially if there's a rough surface. I mean, I mentioned that in the talk. So I'm not sure what XPS is going to cost you. Do you know, Hamish?
Yeah. It depends on what thickness you use. But look, for me, the fact that it's a natural product, and two, if you're involved in, early contractor engagement, and actually working through some of these details, like you might be eliminating your board piers, you might be eliminating strip footings. I mean, in my opinion, and we're actually going through this at the moment, and so it's only anecdotal in my experience. I think you need to look at the whole thing, everything as a whole, and not just one particular element in the slab. Sure, clinker in itself is probably a bit more expensive, but if you can then be creative around how you're putting together that slab, or the build up of that slab, using screw poles instead of board piers, eliminating strip footings and all that kind of stuff, I think you can find some efficiencies in designs there. It all comes down to getting a really good engineering design team on board. But if I'm speaking just comparing XBS and clinker, XBS for a very similar R value is about $55 installed.
So
So
you're
it's a
looking,
little bit more expensive.
depending on where you are, 15 to $20 a square metre more. I think the other benefits of clinker that are worth mentioning is when you think about it from a life cycle perspective, it's the end use of the product. It comes out of the building as good as it went in, and it's easy to recycle, and you can even upcycle it. I mean, it becomes, if it comes out from under your slab in some future time, it could be used as lightweight aggregate to make concrete. It's going to be as good as the day it went in there, and not difficult to use, and also, the other benefit I think is when used in bulk is how it handles moisture. If there is moisture under the slab, or if it gets in there through high rainfall events or whatever, it's not going to wick up through the clinker. So you don't end up with moisture sitting up under the slab. It tends to handle moisture pretty well. It can actually absorb a little bit of moisture, but it can also help it drain away. So in terms of the way it manages the job that it does, I think it has benefits over and above just being a natural product.
I'm going to throw a couple of questions together here. One's from Peter and one's from Corey. I feel like I've answered a few Corey's questions today. I hosted a Australian Passive House webinar today. So what's the minimum order, and what kind of lead times do we have for the clinker?
Currently, and this is just currently, it may evolve, minimum orders 55 cubic meters per order, but that can include multiple products. So it's a delivery. As the volumes expand, and I get a feeling that we'll be working together more too, Hamish, and we've got a lot of inquiries at the moment, because it feels like there's a sort of moment in time where everybody just wants to highly insulate their buildings with natural products. So we're kind of in the right place at the right time. The more volume we get, we might be able to get that minimum order down, but at the moment it's wholesale only, 55 cubic meters, roughly 12 weeks. There's times when it's less than that. If we do have stock, if we are holding stock, we typically don't hold stock of all the different products. The reason is they would be too expensive. We try to keep it as cheap as possible by selling wholesale, doing job lots, job orders, dealing with builders, and rather than selling a pallet here and there. So, yeah.
It sounds like there's a couple of good opportunities here for other like-minded builders who do have upcoming projects, which you could potentially collaborate on if you're in a very similar area. It almost sounds like you might need a distribution partner up here on the mainland, mate. So maybe we can have a conversation about that after.
Yeah, we've got a yard in Gippsland, we have depot, and we have delivery capabilities. But if there's somebody who's interested in that, and it makes sense for them, obviously, upscaling your order for the minimum order, you can use it for the next project. People can buy together, and we're also really open to bulk buy discounts. The more we can buy and sell on to our customers, if there's a few builders get together and they want to order multiple loads, well, we'll definitely sharpen the pencil.
I think you're absolutely right. You hit the nail on the head before, Ryan. I think with everyone wanting to build better, high-performing homes, hopefully Sustainable Builders Alliances contributing to seeing more of these performing homes. We're going to see more and more of these products, more and more of these products being used, and I guess that supply and demand equation, comes into play, and we can see that price come down, especially when we are going to be, hopefully manufacturing or producing them on, in Australia soon.
That's our
We
plan,
have a
Hamish. And
question
just
here.
so you know, we're our goal here is not to be importers. We don't really, the team at Clinka don't want to be importers. We do this so that we have access to the products, and any people we know have access to the products. We put a very small margin on it, and but the idea is that we get our volumes up to a reasonable amount that justifies the investment in that local manufacturing, and at that point the price will come down, of course, when it's made locally. So
Awesome.
anyone who can help us do that, we're happy to talk.
Well, we've got a few people here, which hopefully we can help contribute to that, because I think the product does have some merit. Got a question here from Ian from Keystone Construction. He says the product seems amazing. Why is it not used more widely? Is it cost, supply, not being pushed back from engineers, designers, owners, etc.? I think you've sort of covered a few of those bits and pieces, and I know that you and I talked probably 5 or 6 years ago, and it does seem like right now is the time to kind of pounce on these kind of things, because there's more people wanting to build more healthy homes. But interesting to hear your take on it.
Well, thanks for that's a good question, Ian, and I'd be keen to have a chat to you directly about any of this stuff. But from our perspective, from everybody's perspective, it's really expensive to build, and it's more expensive to build really well. And we all have very high expectations about what our building will do for us, and we all want it to perform as well as possible. But if there's an incremental margin of extra cost on each item, and you're going from cheap double glazing up to high quality double glazing or triple glazing, that's an extra cost. You've got to pick your battles, and I think that we've always had a consistent, strong relationship with our clients and ongoing customers, because once you live in a house like this, I think you really do see the value of it, and I think that there's momentum developing around how many people appreciate that. And it's not just the regulatory environment that's making people build high performance homes, that's part of it, but I think people are putting a value on doing things properly more and more. So we're seeing that change.
So this is a really good question from Elizabeth. And it's a question that's kind of popped into my mind too. Are we in performance solution territory to use these products and the applications that you have described today?
Potentially, depending on your building surveyor or certifier, and it depends on which products you're using in which application. We haven't come across that. I mean, you're using masonry. You're using masonry to provide the same role as non-lightweight masonry. So in a masonry application, no. Single skin wall rendering solutions, yes, potentially. The NCC says that you've got to paint it 3 times with acrylic paint. We try to avoid that and try to use breathable renders. So sometimes that can be a performance solution. In terms of underslab fill, I can't see any reason why this would trigger a performance solution. So I guess the question has more questions, Elizabeth. It depends on your building survey, and it depends on how you're using the products.
I would be interested to see if there's, I guess, some data that we could get access to when we are sort of comparing. If we need to reach a certain R value, if you do have some data that you can share, or some data sheets that
Yep.
does talk through those R values, that'd be really good. Particularly in passive house projects where we really need to be hitting those numbers and putting all that data into PHPP.
Well, we've got the standards that are used for measuring the performance of the products is all published information, so we can provide.
Awesome. Jeremy has a question. So his question is: wet and dry R value under slab. What thickness to achieve R1 wet and dry? Do you roll it with an excavator or a vibrating plate, or do you just rake it out?
Few questions there. I'll work backwards. Up to 150 millimeters thick. It's um, it's more or less self-compacting. We don't vibrate it. Up to 150 thick, it'll just settle into its final form. There might be a small amount of compaction that's very minor once the slab's poured on top of it, but that's taken up by the concrete. Any deeper than that, yes, you can use a vibrating plate, but you've got to put something down underneath it, otherwise it'll bury itself in. You can see in the top right image there is a small machine spreading FCR, as we call it here, fine crushed rock, or crusher dust over the top. So we put a geotextile separating layer, and then compacted FCR on top, or it could be sand. So that can do the job if you're around about 200 thick. In terms of R values, R1 point, I think, about 150 thick, which will give you an anti-capillary layer, so you're not expecting it to be moist at that height. So there'll be a slight amount of moist aggregates at the bottom, but the part above that will provide you with roughly 1.75. Probably be a slight reduction when it's wet, but it would only be wet along the bottom surface. It's not going to wick up through the material. So most of it's not going to be affected by that performance.
You'd see the same.
Question.
You'd probably see the same kind of lowering of your R values if the underside of an XPS board got wet as well.
Yeah, I mean, XPS is pretty good being closed cell, but
yeah, but it's still going to soak up a little bit of moisture though.
My theory is you design for a little bit extra in the clinker. We tend to over excavate our sites and start with like a 7 mil drainage layer or a 20 mil aggregate drainage layer anyway, so that you're working throughout the course of the site on gravel. So you don't get muddy when you're working, but it also allows the water to get away before it gets to the insulating layer.
This is again from Corey. Is there any settings where you can't use clinker for under slab insulation?
If you can't make it thick enough to be useful, I guess, like if you've got a height issue and you don't want to dig a hole in the ground that's just going to fill up with water just to get your clinker thickness in. Let's say you only had 50 millimeters thickness, you'd probably use XPS, or you'd have to then redesign the building to go up higher out of the ground to use clinker. Cost, I guess, it's a premium product from a cost point of view, but we've covered all of that before. It's marginal difference. When else wouldn't you use it? Not sure.
Heights as well. I think you might have touched on that before. If you're restricted by building heights.
Yeah, I think that's right. Yeah, because it's going to be 3 times the thickness of the same piece of XPS.
Is it possible to fix a batten system to the clinker block walls?
Yes. We've done that with timber cladding on a project we did in Gippsland at Newham South. So we used, you just use lightweight masonry anchors, which all the fixing companies have got now. They're either helical screws, or you can use a plug screw, which are preloaded. And if you want, you can glue it. It takes adhesives really well. So with the batten system, if you wanted to use the belt and braces method, you can see how this reinforcing's been set up. That's just temporary, of course, just to get it in the correct position for the retaining wall. But that's just screwed in with batten screws, which they hold it for a little while, but they don't hold it forever. But if you use the right fixings, it's rock solid. We've even used helical screws to fix roller door tracks too, and they take a fair bit of load with movement. So, but a bit of adhesive and some fixings will put a batten in. You can go both ways, and then cover it with timber and ventilate the cavity or not.
I have another question here. Interesting question. Is the product used in conjunction, or can the product be used in conjunction with waffle pod slab construction? That's the first part of the question.
Should I answer that bit first?
Yeah,
Yes.
answer that away. Yeah.
So yeah, you could fill your whole site up with clinker fill and then put your waffle pod on top of it. But it's probably going to be not cost effective to run it out everywhere. But a waffle pod, given that it sits on the ground, the question would be, how do you contain the clinker at the edge where it's sitting?
Yeah, I was thinking the same thing too. And
You might
the
need
rest of the question is
you might need to do a
if so,
strip footing at the perimeter, a clinker block, then clinker fill, then your waffle pod. But then it begs the question, why would you use the waffle pod? I guess it gives you height if you want height. I'm not a big fan of waffle pod systems, only because I worked with an engineer many years ago who I won't name, but he spent a lot of time in courts acting as a expert witness for failed waffle pods, which was very quiet in the industry, and hence why I won't name him. But he didn't do the designs. He was just acting as the expert witness in the cases, and that just scared me off them. And I haven't heard anything otherwise. I mean, they could be totally fine, and they were just. I think the issue with them mostly is people don't put enough concrete on the top, or there's a risk that not enough concrete is put over the pods.
I think there's quite a bit to unpacking this question. So what I might do is suggest that the attender who asked this question maybe send Ryan an email. Ryan, maybe I'll get you to tell everyone what the best contact is for you at the end, maybe so we can unpack a little bit more, because it does go on to talk about it's a reactive site and it's a passive house and all that kind of stuff. So
Yeah, sure.
there is a little bit to unpack there.
Well,
And I think I might
that's how we met. I mean, all people need to do is go to the Clinka website, which is clinka.com.au, and they can find contact details and other technical information. But yeah, my job is to take inquiries if people want to have an option for how they do it. If they've got a sketch design or a drawing or even a preliminary engineer's design, we can provide options for them and show them how one or two or three different ways that you might be able to use Clinker products around the perimeter and under the slab.
This is a really great question from one of the other directors of Sustainable Builders Alliance, Jeremy Spencer, and it is: do we have the right clay here in Australia for clinker?
The answer, Jeremy, is yes, and that it is super abundant.
Could you maybe, pardon the pun, expand on that a little bit, and what kind of clay we actually need for the clinker product?
It's a type of bentonite, and I think there may have even been some small scale manufacturing of expanded clays in the 60s, because it was used to make some multi-story buildings as lightweight concrete elements in some buildings in the 60s, where there's an Italian engineer who did some work with expanded clay aggregates, and there was some experimentation around doing it. There's also been some tests that have been done in the past of expanding, certain types of clays that don't get the lightweightness that we have in our products, that are still relatively dense, probably more like scoria. But there's many different types of clays in different areas, and you've just got to find a deposit of the right stuff. The good news is, from an environmental point of view, it's shallow mined. So if it's, say, a farm, and you can find that clay at shallow depths, it's easy to get at, and you can reinstate the topsoil after that area is mined and make it back into farmland again. So it's not necessarily a high impact process. We've identified a few locations, but we've just got to figure out commercially which is the best place to do that. But the good news is that the way that the green energy industry is going, it's looking likely that hydrogen-based fuels for manufacturing and also for logistics will mean that this will be effectively zero carbon product at the time it's manufactured in Australia.
That's good news to hear. This next couple of, I've got a few more questions here, and then we'll round it out. This is from Sean. Does it retain its R value when it's wet? I think we did touch on that before.
No, it's reduced But like I said, if you do your drainage right, the product has anti-capillary properties, so it won't wick moisture up through the layers into the bulk of the material. So if you slightly oversize it, you'll presume that the bottom section will still provide some insulation, but be slightly damp. But in most cases, it's dry and it has its full capacity.
I'm absolutely loving the question that Elizabeth is throwing at us today. Obviously, when we think about embodied energy, there is a bit of an issue with this as a shipped product. Have you done an LCA, and is it possible to see emissions data?
Yeah, so I mean the kilns are currently fired with gas, so they do use a non-fossil fuel, which is why we want to do it properly when we establish that in Australia. Shipping, Elizabeth may know this, but international, maybe not. I was surprised when I heard it, but shipping is relatively low emissions way of delivering a unit particle. So if you're delivering a container load of product, it doesn't add significantly to the embodied energy of the product. It does add to it. I think I can't remember exactly. We have done figures, but I can even talk to Elizabeth directly about that. We do have data on it. We've done data analysis in comparison with other products. We've worked with eTool. I gather some of the people attendees would know eTool, and they do LCAs. There was an LCA done on this Mount Nelson Sustainability Learning Centre. So I gather the data's in their back end. So anything people would like to know about that, feel free to contact me directly.
I think it's really good that the product obviously sounds fantastic, and I think it's really good that we're kind of trying to tease out a lot of these little things because we obviously want to be saying that a product is green and is sustainable, all that kind of stuff. And from what you're telling us, it does sound like it is. I reckon we have time for one last question. And it is, I have a question regarding the use of clinker fill 10 to 20 and clinker hill 2 to 10 crushed in green roofs. Past research and projects have revealed to me that the best performing green roof requires 7 layers, rigid insulation, waterproof and anti-root barrier membrane, drainage cell wrapped in landscape fabric, sand, topsoil, jute fabric. If using the clinker pill and fill, would it eradicate the need for rigid insulation, drainage layer, and sand?
Okay, that's a good question. I've personally done a few of these and have a bit of a passion for green roof construction. And I think the person meant to write clinker fill. Clinker pill might be a typo.
I think so, maybe.
But the answer,
Yeah.
the good news is the answer is yes. We've built green roof, warm roof, green roof construction. So insulation on the outside of the membrane. And we've used XPS and we've used clinker fill 10 to 20 mil aggregates. So if we were the question, who was asking that question, Hamish?
There was an anonymous attendee.
Anonymous. Well, I'm not going to be able to help him directly, but I'll tell him what we found. You just need to have a higher parapet. Basically, you just need more thickness. But the good news is that if you can adjust your parapet height or whatever's containing your green roof, you can go structure, membrane, some sort of geotextile protecting layer, clinker fill as a drainage layer, and that can be quite thin, but it does. So it's acting as a support for the structure for the green roof above, but it's also acting as a void for the water to pass through. But it does still provide insulation, even if it's damp. And then you do another geotextile layer, and then you go into your growing media and your root barrier, whatnot. So we've got a few different examples of how to do that. And if Anonymous wants to email me and ask that question, I can send them some cross sections and talk to them at length, because it's my little nerdy subject that I could talk about for hours.
It certainly got me thinking about a home that we'll build on the new property that we bought at some point, having a green roof. I'm conscious of your time, Ryan, so I might wrap it up. Thank you very much for the presentation. I'm hoping that it's been incredibly informative to everyone that's joined us today. And thank you to everyone who's joined us tonight. Don't forget to listen to episode 19 of our podcast. I know for those of you who do listen to our podcast, it is a little bit out of sequence. This was actually recorded before our director's podcast. So this is going back a couple, but it is 19. Simon and Brian catch up with Nathan Pert, who will educate you on bushfire attack levels. And you can check that out on Spotify, Apple, or wherever you listen to your podcasts. I'm really excited about the next webinar we're doing, and I think Zara was actually joined us tonight. So we're going to be joined by building biologist Zara Dakota, and she's going to be talking to us all things healthy homes. And then another exciting guest who I also believe was on tonight's webinar, Jenny Edwards from Lighthouse Architecture and Science, is going to be presenting in October, which is very exciting. Now, we've got some huge news for any of you who follow us along, and for those who do follow us know that we are rebranding. We're not dropping Builders Declare, we're just rebranding to Sustainable Builders Alliance. So we're still going to be carrying the flag for Builders Declare, but we are relaunching as SBA. And all of you are invited to our launch event, which is on Thursday, the 21st of September at 5:30 at Stomping Ground Brewery in Collingwood. There will be food and there will be some refreshments provided. Don't think it is an open tab, but there'll be a few beers there for all of us to enjoy. Now, lastly, if you do love what we do, we are inviting all of you to become gold or silver sponsors for Sustainable Builders Alliance. We have 10 fantastic platinum sponsors, which we'll talk about at the launch. We really appreciate all the support you've given us over the last 3+ years. You know, we're coming on 4 years now, which is incredible. And we really want to continue to deliver really valuable educational content for many, many, many years to come. This takes time, this takes effort, this takes money. Now, I can categorically say that as the directors of Builders Declare, we do not make any money, we don't draw a wage, we do it because we really believe in the information and what we're trying to do for the building industry. But if we can generate some income, it allows us to provide better educational content for you guys. It's going to allow us to put on more events. It's going to allow us to kind of sharpen up our organisation a little bit more because we can bring in some external help. If you would like to become a gold sponsor, it is a very reasonable $1,000 and it gives you a 12-month exposure. And it gets you featured on as one of 3 sponsors on 2 of our podcasts. It gives you brand promotion on the Sustainable Builders Alliance Instagram page and Facebook pages. And you get your logo and a hyperlink on the new SBA website, which we're going to be launching at that launch event on the 21st. And you get the goodwill in aligning yourself with the Sustainable Builders Alliance. Now, the silver sponsorship, I think, is an absolute steal. If it was up to me, I would have jacked up the sponsorship prices, but I was outvoted. This is $500. $500 gets you brand promotion on Sustainable Builders Alliance Instagram page and Facebook pages, logo with your hyperlink on the new SBA website, and again the goodwill in aligning yourself with Sustainable Builders Alliance. Thank you again, Ryan. Fantastic presentation, and thanks to everybody who joined us today. I will get this recording up onto YouTube soon. I will see all of you on the 21st of September at Stomping Ground Brewery. And I believe the following week is when we're going to be having Zara on. So you can get in contact with us, info@buildersdeclare.com. You can join in the conversation on Facebook, on our Facebook page and Instagram. Ryan, do you want to just throw out your email if they want to get in contact with you for any further information?
No worries. Thanks, Hamish. It's Ryan, RYAN, at Clinka, CLINKA.com.au.
Awesome.
Thanks for having me, Hamish.
No worries. And just quickly, it was Melinda who was the anonymous, and Ian, the date is the 21st of September, and it's at 5:30 in Collingwood. Stomping Ground Brewery. We will. There is a link in our on our Builders Declare Instagram page in Linktree, so you can go and register there. So anyway, thanks everybody. Ryan, thank you so much.
Thanks, Hamish.
See ya.
Good on you, mate.
Bye.
See you later.